Hello, look here, we have a projectile motion. And you know, in a projectile motion, the velocity keeps changing because of gravity. So it looks like a very complicated problem, but actually, there's something very simple about it, yeah? So let's suppose you have a projectile whose current velocity is this much. Give it a duration of time of delta t, the velocity is going to change by this much g delta t. So this is your current velocity, this is the change. What is your new velocity now? This, right? Just do the vector summation. So give it a bit more time, the velocity will change to this, a bit more time, it will change to this, a bit more time, it will change to this, and so on. Now, do you notice something about these velocities here? Yep, their horizontal component are the same, isn't it? The horizontal component of the velocity does not change because gravity can only cause a downward vertical change in your velocity. So your horizontal velocity is fixed. So now if you look at projectile motion again with this new insight, then you know that if you resolve the velocities into its horizontal and vertical components, then the horizontal components are constant. They don't change. Whereas the vertical component does change, yeah? In fact, it changes by about 9.81 meters per second every second. So actually, projectile motion is very easy to solve as long as you split the projectile motion into a vertical and a horizontal motion. It's always easier if you use an example, yeah? So read the problem yourself first. So this problem is about a projectile, a cannonball fired with a launch speed of 120 meters per second at an angle of 25 degrees above the horizontal. So it's going to go pew, boom, right? So we are supposed to find out the speed and the position of the cannonball 8 seconds later. So the key to solving projectile motion is to do the horizontal and vertical motion separately. So first step is always to resolve the launch velocity into its horizontal and vertical components, which is these two numbers here, yeah? So 8 seconds later, what would be the speed? Well, I don't know about the speed, but I know damn sure that the horizontal velocity will remain as 108.8 meters per second. Because horizontally, the projectile is just moving at a constant speed forward, yeah? So we have got the horizontal component. What about the vertical component? For the vertical component, it's uniform acceleration motion with a constant acceleration of negative 9.81 meters per second square if you are using upward to be positive, yeah? So it's the same old equation you use as if you are solving a vertical throw problem, just that you got to be careful. The u you put here must not be 120 meters per second. It must be the vertical components only. Remember, we are solving the vertical motion separately. So the numbers you put in, make sure they are vertical components. So your calculator tells you that the vertical component 8 seconds later is negative 28 meters per second. Negative, what does that mean? Downward lah, huh? Because we use upward to be positive, right? So that means 8 seconds later, maybe you are somewhere here with a horizontal component of velocity of this much. This component doesn't change, remember? And the vertical components, we have calculated it to be downward about 28 meters per second. So what is the speed? Just do the Pythagoras. Easy? Okay, so now we know the speed. Let's proceed to calculate the distance, yeah? That means the distance between here and here. So how do you do such a calculation? Easy, just split into vertical and horizontal motion. So we're going to calculate the horizontal displacement first, and then we're going to calculate the vertical displacement, and then we do the Pythagoras, right? Good plan, yeah? So the horizontal distance. Remember, horizontal motion is a constant speed motion. Even PSLE students know how to do such calculations. It's just distance is equals to speed times time, yeah? So use the horizontal component of velocity times the time. You get the horizontal displacement. As for the vertical displacement, use the Suvet equation, use the ST equation here. Again, be careful, the number you put in here, remember, it must be the vertical component. So now that we know the horizontal and the vertical displacement, just Pythagoras them together. Alright, so let me say it again. The key to solving projectile motion problems is to solve the horizontal and vertical motion separate. Alright, that's all. Ta-ta!